Hello, hello, I'm Breton, one of our MCAT tutors here at Inspira Advantage, where we help students get accepted into med school and other professional programs. Today we're going to start off with practicing what we learned in our previous video about the differences between Arrhenius acids, Bronsted-Lowry acids, as well as Lewis acids and bases. So you can try this on your own, because it's one thing to hear me speak, but there's another to see if you can do this yourself. So what I want you to do is take a look at this first guided practice problem and tell me, well, figure out which one of these is going to be acid, which one's going to be the base, and then what type of acid or type of base it could be. And keep in mind, it could be only one type of acid, it could be two types of acid, or it could be even be all three types of acid. So this is a great time to pause your video, try and think about it. Okay. So you've had some time to think this one through, and we're starting off very complexly here. If we look at what's going on here, we have all three types for both the acid and the base. So this is an Arrhenius acid, a Bronsted-Lowry acid, as well as a Lewis acid, and same for the bases. Okay, so we figured that out, but which one is the acid and which one is the base? The dead giveaway on this one is that hydrogen hanging out right by bromine. I'm going to color that red to tell us this is our acidic group. Well, where's our base? Well, if we find the acid, we know the other one must be the base. We know in this case that water is acting as a base. So let me redraw water to make it even more clear. Let's say we've got something like this. So now that it's in blue, it becomes even more clear that, oh, okay, the water is acting as that base, creating the hydroxide. So because water is producing a hydroxide, that makes it an Arrhenius base. Because it is donating electrons, it is a Lewis base. Because it is accepting electrons, it is a Bronsted-Lowry base. Crank up the difficulty here. Take a moment and think about what are the different, which one of these is the acid, which one of these is the base, as well as what type of acid and base. Go ahead and pause. All right, so you can go ahead and unpause. So this one, kind of tricky. First, I'll tell you that our SnCl4, this is our acid, and water is acting as a base. Okay, how do we know? Well, we want to look at our products here. Will help guide us. So first, we know that the water is donating So first, let's take a look at how SnCl4 is an acid. So we see that it's a Lewis acid because it's going to be accepting electrons from the water. The reaction happening here is each time, I'll draw it out here for you. So we've got our SN, Cl, 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 Cl. Then when we have water coming in here, put out my oxygen right here. Oxygen is going to go right up here, kick one of these off, then we're going to get tin, chlorine, 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 OH with another H. And since this is positive, this still isn't stable. So we're going to have another water clean up that hydrogen, leaving us with a nice evenly charged tin in the middle with just a hydroxide stuck on there. So this reaction, let me move it down a little here. This reaction is going to repeat 4 times until eventually all of those chlorines are going to be replaced with hydroxides. Once we've replaced all those hydroxides, we're done. That's where we're getting this from. But how about the 4HCl? Well, let's take a look. So this chlorine, let's zoom in on the chlorine here. Let's say we now have our chlorine just floating out and about. This is just a negatively charged chlorine. And from here, from our water cleanup step, we're getting H3O plus. Well, this means we have an extra hydrogen. What are we going to do with that? We have a positively charged water, we have a hydronium ion, and a chlorine. Well, that is a match made in heaven. Let's take this guy down here, expand him a little bit so it looks a bit nicer. It's just going to go right like this. And you just made HCl. So these are where all of our products are coming from, and it really helps to see this for the next explanation to make sense. Okay, so we know our acid, and we know it's going to be say, Lewis acid, because it is accepting electrons. It's not producing hydrogen, so we can't call it an Arrhenius acid. And since we can't call it an Arrhenius acid, we can't call it a Bronsted-Lowry acid. And then we've solved it. That's done for the acid. But the base gets kind of weird here. So our water is producing hydroxides. We're producing hydroxides right here. Here's our hydroxide. So water is going to act as, you guessed it, an Arrhenius base. Water is going to act as an Arrhenius base and a Lewis base. And we want to remember that a Lewis base is going to donate electrons. Well, is this happening? Yeah, right here. If we look right here, these electrons are being donated to tin. Oh, okay. That explains why water's acting as a Lewis base. Thank you for watching our video on the different types of acids and bases, and I'll see you next time.